Hello students, welcome back. Today we will start chapter 8, Introduction to Structured Query Language, that is SQL. We have already learned relational database management system and purpose in the previous chapter. There are various relational database management systems such as MySQL, Microsoft SQL Server, PostgreSQL, Oracle that allows us to create a database consisting of relations and to link one or more relations for efficient querying to store, retrieve, and manipulate data on that database. In this chapter, we will learn how to create, populate, and query database using MySQL. Structured Query Language SQL. Children, as you already read in previous chapter, one has to write application programs to access data in case of a file system. However, for database management systems, there are special kind of programming languages called query language that can be used to access data from the database. The structured query language is the most popular query language used by major relational database management systems such as MySQL, Oracle, SQL Server. SQL is easy to learn as the statements comprise of descriptive English words and are not case sensitive. We can create and interact with the database using SQL in an efficient and easy way. SQL provides statements for defining the structure of the data, manipulating data in the database, declare constraints, and retrieve data from the database in various ways, depending on our requirements. Students, before using MySQL, you need to install it on your computer. Now let me explain you how to install MySQL. Students, MySQL is an open source relational database management system software which can be easily downloaded from the official website https:/dev.mysql.com/downloads. Click on the download button for the community server and choose from the list of supported platforms which include 32-bit and 64-bit Windows and a few others. After the installation file has finished downloading, double-click it, which begins the MySQL setup wizard. At the Welcome dialog box, click the Next button. The MySQL setup wizard allows us to choose the installation directory on the computer and whether or not to have optional components installed. In the setup dialog box, choose typical from the three options. MySQL will be installed in the default directory. Now click the Next button. Now it is ready to install MySQL files. Click the Install button. After the setup is complete, we should configure the new server. Now students, how to configure MySQL? At the Initial Server Instance Configuration Wizard dialog box, click the Next button. Keep selecting the default options provided in subsequent windows. If the configuration does not encounter any errors, then information will be prompted that the configuration file was created. MySQL Server was installed and started, and the security settings applied. In the process of configuration of MySQL, a prompt for password will be displayed. Here, you should enter a password and remember this password as it will be required each time to start MySQL. Now students, testing MySQL. Steps to test MySQL is click on the Start button, click on Programs, click on MySQL folder and select MySQL command line client. MySQL will prompt a message to provide password. It requires the same password which was entered during the installation. Students, to exit from MySQL, type quit or exit at MySQL prompt. Students, there are few rules to follow while writing SQL statements in MySQL. These rules are: SQL is case insensitive. That means name and capital name are same for SQL. Always end SQL statements with a semicolon. To enter multiple SQL statements, we don't write semicolon after the first line. We press enter to continue on the next line. The MySQL prompt then changes to underscore greater than sign, indicating that statement is continued to the next line. After the last line, put semicolon and press enter. Data types in MySQL. Now let me introduce you with data types. Data type indicates the type of data value that an attribute can have. The data type of an attribute decides the operations that can be performed on the data of that attribute. Commonly used types in MySQL are char. It specifies character type data of length n, where n could be any value from 0 to 255. Char is of fixed length, means declaring char 10 implies to reserve spaces for 10 characters. If data does not have 10 characters, MySQL fills the remaining characters with space padded on the right. Varchar n specifies character type data of length n, where n could be any value from 0 to 65,535. But unlike char, varchar is a variable length data type. That is, declaring varchar 30 means a maximum of 30 characters can be stored, but the actual allotted bytes will depend on the length of entered string. Int specifies an integer value. Each int value occupies 4 bytes of storage. The range of values allowed in integer type are -214, 748, 3648 to +214, 748, 3647. For values larger than that, we have to use big int, which occupies 8 bytes. Float data type holds numbers with decimal points. Each float value occupies 4 bytes. Date data type is used for dates in YYYY, DD format, where YYYY is the 4-digit year, is the 2-digit month, and DD is the 2-digit date. Now let me introduce you with constraints. Constraints are certain types of restrictions on the data values that an attribute can have. They are used to ensure the accuracy and reliability of data. However, it is not mandatory to define constraint for each attribute of a table. Commonly used SQL constraints are not null, unique, default, primary key, foreign key. Not null ensures that a column cannot have null values, where null means missing, unknown, or not applicable value. Unique ensures that all the values in a column are distinct or unique. Default data type, a default value is specified for the column if no value is provided. Primary key, the column which can uniquely identify each row or record in a table. Foreign key, the column which refers to a value of an attribute defined as primary key in another table. Categories of MySQL commands. Students, SQL commands can be classified into two categories: data definition language and data manipulation language. Data definition language DDL commands. The DDL part of SQL permits database tables to be created or deleted. It also defines keys, specifies links between tables, and imposes constraints on tables. Examples of DDL commands in SQL are: create database, it creates a new database; create table, it creates a new table; alter table, it modifies a table; drop table, it deletes a table. The data manipulation language DML commands. The query and update commands form the DML part of SQL. Examples of DML commands are: select, it extracts data from a table; update, it updates data in a table; delete, it deletes data from a table; insert into, it inserts new data into a table. Students, let me explain you how to create a database. Create database statement is used to create a new database. Now, how will you write this statement in front of the MySQL prompt? Type create database and the name of database. For example, create database school. Statement gets executed. A database with the name school is created on the system. Now you have to open the database to work on it. For this, use statement is used to open the database. For example, use school will open school database. After creating database, we need to create table in this database and specify attributes for each table along with data types for each attribute. This is done using the create table statement. Syntax of create table statement is create table, table name, then column name 1, data type 1, column name 2, data type 2, so on. For example, create table student, roll number int, s name varchar 20, s date of birth date, guardian GU ID char 12 will create a table student with the given fields. Now students, you want to see the structure of an already created table. For that, describe or DESC statement is used. Its syntax is describe table name. For example, DESC student. Once this statement is executed, it will display the structure of table student as shown on the screen. Show table statement. Show table statement is used to view names of all the tables contained in the current database. For example, show tables will display the name of the tables in the current database. Alter table. Alter table statement is used to change the structure of a table, that is, add, remove, or change its columns. Alter the statement alter table student add games varchar 20 will add a column named games in student table. The statement alter table student modify the statement alter table student modify games integer will change the data type of the newly added games column to hold integers in place of character data. The statement alter table student drop games will delete games column of a table. Drop statement is used to remove a database or a table permanently from the system. Insertion of records. Students, when we create a table, only its structure is created, but the table has no data. To enter records in the table, insert into statement is used. The syntax is insert into table name, values, value 1, value 2, and so on. Here value 1 corresponds to attribute 1, value 2 corresponds to attribute 2, and so on. For example, insert into student values 1 Athar Bhoja 2003 05 15 44444444 will insert this record into table student. Now students, you want to retrieve data from the table. For that, select statement is used. The statement select roll number from student will display roll number of all students. The statement select roll number, name from student will display two columns, roll numbers and names of all the students. Students, we can display columns in any order by specifying the columns in that order in the select statement. The statement select name, roll number from student will display names first and then roll numbers from the student table. Students, to see all the columns of the table, we can write asterisk in place of names of all the columns. The columns are displayed in the order in which they are stored in the table. The statement select star from student will display all the columns of the student table. Renaming of columns. In case we want to rename any column while displaying the output, we can do so by using alias as in the query. The statement select marks 1 as marks secured from student while displaying query result rename marks 1 as marks secured. Distinct clause. Using the keyword distinct, the duplicate values can be eliminated in the result. By default, SQL shows all the data retrieved through query as output. However, there can be duplicate values. The statement select marks 1 from student without the distinct keyword shows 7 rows. While the same query select distinct marks from student with distinct keyword shows 6 rows as duplicate data 93 is displayed only once. Students, tables usually contain many rows. Mostly, we do not want to display all the rows of a table. Certain rows can be displayed based on the criteria for selection of rows using the keyword where. The where clause is used to filter records. It is used to extract only those records that fulfill a specified criteria. For example, the statement select name, marks 1 from student where marks 1 greater than 80 will display the names and marks of all the students who have secured marks above 80. Relational operators. Relational operators are used to compare two values. The result of the comparison is true or false. They are used with where clause. The relational operators used in MySQL are equal to, greater than or equal to, less than or equal to, not equal to. For example, the statement select star from student where marks 1 greater than equal to 93 will display the details of students who have secured at least 93 marks. Logical operators. The logical operators and, or, and not are used with where clause to combine multiple conditions. For example, the statement select roll number, comma marks 1, comma name from student where marks 1 greater than 70 and marks 1 less than 80 will display roll numbers and names of students who have secured marks above 70 but below 80. The statement select star from employees where salary greater than 5000 and DPT ID D04 will display all the employees who are earning more than 5000 and work in department with department ID D04. The statement select star from employee where not ename is equal to Alia will display records of all the employees except Alia. Between operator. The between operator defines the range of values within which the column values must fall into to make the condition true. The range includes both the upper and lower values. The statement select roll number, comma name, comma marks 1 from student where marks 1 between 70 and 80 will display roll numbers and marks of students who have secured marks in the range 70 to 80 including 70 and 80. The statement select roll number, comma name, comma marks 1 from student where marks 1 not between 70 and 80 will display roll numbers and marks of students who have secured marks other than the ones in the range 70 to 80 including 70 and 80. In operator. The in operator compares a value with a set of values and return true if the value belongs to that set. The statement select roll number, name, marks 1 from student where marks 1 in 68, 76, 78 will display data of students whose marks 1 are 68 or 76 or 78. The statement select star from employee where state not in Delhi, Mumbai, UP will display all rows except those that have state as Delhi or Mumbai or UP in the employee table. Order by clause. Order by clause is used to display data in an ordered form with respect to a specified column. By default, order by displays records in ascending order of a specified column values. To display the records in descending order, the DESC keyword needs to be written with that column. The statement select star from employee order by salary will display details of all the employees in ascending order of their salaries. The statement select star from employees order by salary DESC will display details of all the employees in descending order of their salaries. Handling null values. SQL supports a special value called null to represent a missing or unknown value. In order to check for null value in a column, we use is null. The statement select star from employee where bonus is null displays details of all those employees who have not been given a bonus. This implies that the bonus column will be blank. The statement select ename from employee where bonus is not null. Displays names of all the employees who have been given a bonus. This implies that the bonus column will not be blank. Substring pattern matching. Students, many a times we come across situations where we don't want to query by matching exact text or value. Rather, we are interested to find matching of only a few characters or values in column values. For example, to find out names starting with T or to find out pin codes starting with 60. This is called substring pattern matching. We cannot match such patterns using equal to operator as we are not looking for exact match. SQL provides like operator that can be used with where clause to search for a specified pattern in a column. The like operator makes use of the two wildcard characters. These are the percent symbol and the underscore symbol. The percent symbol is used to represent any sequence of 0 or more characters. The underscore symbol is used to represent a single character. The statement select star from employee where ename like K% displays details of all those employees whose name starts with K. The statement select star from employee where ename like %A displays details of all those employees whose name ends with A. The statement select star from employee where ename like underscore ANYA displays details of all those employees whose name consists of exactly 5 letters and starts with any letter but has ANYA after that. The statement select ename from employee where ename like %SE% displays names of all the employees containing SE as a substring in name. The statement select ename from employee where ename like underscore A% displays names of all employees containing A as the second character. Data deletion, updation and deletion. Students, updation and deletion of data are also the parts of SQL data manipulation. In this section, we are going to apply these two data manipulation methods. Data updation. We may need to make changes in the values of one or more columns of existing records in a table. For example, we may require some changes in address, phone number, or spelling of name. The update statement is used to make such modifications in the existing table. For example, the statement update student set marks 1 is equals to 94 sets the marks of all the rows to 94. The statement update student set marks 1 is equal to 94 where name equal to Monica Rana sets the marks of the row with the name as Monica Rana to 94. Students, multiple columns can also be updated at once. The statement update student set name equal to Chavi Chana, marks 1 equal to 90 where roll number equal to 15 changes the name to Chavi Chana and marks to 90 for the roll number 15. Data deletion. The delete statement is used to delete one or more records from a table. Suppose one of the students with roll number 14 has left the school and you want to delete his or her row. Use the delete statement. For example, the statement delete from student where roll number equal to 14 will delete the student record with roll number 14 from the student table. Student delete statement can be used to delete all rows of the table also. For example, delete from student statement can be used to delete all the rows from the student table. We can verify it by using the statement select star from student.